Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today, for June 7th, 2018, exam FM on financial mathematics. A bond has a modified duration of 8 and a price of $112,935, calculated using an annual effective interest rate of 6.4%. MAC subscript E is the estimated price of this bond at an interest rate of 7% using the first order Macaulay approximation. And MOD subscript E is the estimated price of this bond at an interest rate of 7% using the first order modified approximation. Calculate the difference of these two, Mac E minus mod E. Okay, so when the approximation is based on duration defined with respect to the interest rate I, the approximation of the change in price divided by the price is, that's approximately, minus the duration times delta I, where delta I is the change of the interest rate. So that delta P is approximately minus D times delta I times P. Now you absolutely have to remember that. That comes from the fact that delta P divided by delta I and then divided by P, that's an approximation of minus the duration, because the duration is minus the derivative of the price with respect to the interest rate divided by the price. In this case, P is equal to 112,955, D is 8, delta I is 7% minus 6.4%, so 0.6%, that's the change in interest rate. So that delta P is minus 8 times 0.6% times 112,955 and comes out to be negative 5421.84. So if interest rate rises from 6.4% to 7%, the change in price is a decline of 5,421.84. And this mod E, the new price approximated with respect to interest rate approximation, is previous price minus that amount, and that comes out to be 107,533.16. The corresponding first order Macaulay approximation using Macaulay duration, which is defined as minus the logarithmic derivative with respect to force of interest delta, not with respect to interest rate. That's P of delta plus delta, sorry that it's delta, but that's what it means. That's what this is. The first symbol is capital delta, the second one is lowercase delta. Capital delta is the change, and lowercase delta is the force of interest, divided by P of delta is approximately equal to e to the minus dm times delta, where dm is the Macaulay duration. That means that the new price, P of delta plus delta, is approximately the old price times e to the minus dm times delta. In this case, the original price is given as 112,955. The Macaulay duration, so remember the modified duration, which is just duration, is obtained by taking Macaulay duration and dividing it by 1 plus the interest rate. So Macaulay duration can be obtained from regular duration by multiplying the regular duration by 1 plus the interest rate. So dm is 8 times 1.064. And delta, well, how do you calculate the force of interest from interest rate? 1 plus I is equal to e to the delta. So that delta is the natural logarithm of 1 plus I. So the change in delta is natural logarithm 1.07 minus natural logarithm 1.064. And this approximation using the force of interest is the price at delta plus delta delta, which is the current price, times e to the minus dm times delta delta, and we just plug in all the numbers. And of course, natural logarithm of 1.064 minus natural logarithm of 1.07 is the natural logarithm of the ratio of them. Now, one thing I want you to notice here is that there's a minus in front of dm. You don't see it in front of 8 times 1.064, but I changed the order of delta delta. I have it now as ln of 1.064 minus ln of 1.07, where delta delta is ln of 1.07 minus ln of 1.064. So putting a minus in front of it switches the order of the subtraction. That's why you see this. And then, of course, e to the those difference of natural logarithms is the same as e to the natural logarithm of the ratio of the two. And e to the ln of something is just that something. So this becomes 112,955 times 1.064 divided by 1.07 to the power 8 times 1.064. And we just calculate it to be 107,675.74. And the difference of the two quantities is 107,675.74 minus 107,533.16, and that's 142.38, which is answer E. So it's important that you know these approximations. This is likely to be on the test. You should know these. The first one is absolutely obvious. The second one is it's the direct consequence of the definition of Macaulay duration as minus the logarithmic derivative with respect to the force of interest. Anyway, answer E. Please remember this is copyrighted material. The problem itself comes from a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.